You are listening to a piece of the Salasin.10 podcasterium. You are listening to a piece of the Salasin.10 podcasterium.
Pretty much, I do a lot of solution architecture, system administration for variants, training in Python, then Office Matter, stage. You can see because I came from an animation background with computer science technique. So I tend to be a bit of a graphics as well as the art side as well as the computer science side. I also do content development, doing graphic artwork, layout, application developer. I did a lot of animation production management system, pipeline, preschool management system. So if you know someone who's starting a new preschool that needs to have their records managed, happy. Very recently, I'm getting involved in the archery tournament management system to help manage the archery games. I'm also the lead organizer for Vendor User Group Singapore and co-admin of Facebook group, Vendor Knowledge Base and Vendor PD. You can find me easily by looking at searching through for my I don't think that these are pretty much the slides I hope that you can see. Other than that, everything else is before. Okay. I need to give you guys a bit of an expectation. Before that, I need to also know this particular course workshop right now. This really shouldn't even be called a workshop. It's more like a crash course. Because in other workshops that I've actually done or attended, they actually split this up at least to about 4 lessons, but you guys are crashing it into about 4 hours, maybe 6 hours, 4 to 5 hours. Okay, so and it is actually for really absolute beginners. It's like people who have never programmed before. One thing is because I'm very used to doing that. Came from, like I said, I worked in an animation production pipeline for quite a bit before I freelanced on my own. Most of these are actually artists that actually don't touch code at all. I mean, just the notion of reading itself actually is scary for the artists. They like to paint and draw and do stuff, but just not read things. Okay, so to actually get them to actually start learning Python was actually quite a miracle. What happens is that most of the time, they'll be seeing me trying to do some very simple stuff. And because I've actually helped them migrate from Windows to Linux operating system and the whole stack from Maya to Blender, Illustrator to Inkscape and Photoshop to GIMP. So I converted an entire animation studio into using purely open source software. And the beauty part of it is that got the artists interested was actually the desktop environment. Because for once they can customize it to anyhow they like it. And the moment they customize to anyhow they like it, each desktop that you go through is actually very different. And you'll be like, okay, where do you put your icons? But then with the sysadmin, we're so used to alternate F2. We start the command line, and we'll do our magic from there. So many of them discovered that the moment I open up my command line, I type in Python because the questions that they ask me usually are Python. So to a certain extent mathematical. So instead of open up the calculator and start typing things, I'll just open up Python, the terminal, Python, and then I do my starter. So monkey see, monkey do. The artists picked it up. Sometimes they'll do their own calculation. They'll open an F2 terminal, Python, and then they start using Python as a calculator. Then of course the technical directors or the artists that are more technical, like people doing rigging and things like that, start getting into Python scripting because it is the native scripting in Blender. And of course, nowadays Maya and other software start to pick it up, and you can see that Python is pretty much everywhere where code is necessary. Okay, the way I designed this course is for, really people that have never programmed before, who have never seen code before, or, in my description that I've written up, it's really for, people, the code that they see probably is in Hollywood, movies. They see a few lines scroll through, and that's pretty much the code that they see. Okay. Now, in designing this workshop, please don't expect that you can really start to, program the next big thing out there. All right, it's just to keep everybody's expectation, on how, the reality. Learning a language is not easy. Even with, Python actually has made it damn easy. That's one thing I can tell you. For entry to understanding something, to actually get something working, Python actually did a very good job on this. The way they do the syntax, the way they do the organization, versus say other languages like even Java. Okay. I have, for me, embarrassingly, I have still problem picking up JavaScript. But I still have to do it because when I'm doing web app development. Thing is that my peers who did JavaScript find that it's so easy to pick up Python. Okay, so you can see the amount of ease, over there. One thing I'd like to know too is that what are your motivation for actually taking this class up? Just give me a short one sentence to do.
Just familiar with the Python syntax.
I do game development and security.
Sorry?
How Python
Works. You guys might have to yell a little bit. Just student, okay? Sorry?
I'm
Teaching. What kind of code are you doing? Application development. Any calculation? Okay. What's it called? Students. Switching, okay. Analysis. If you already have some language background, you might just find this part a bit boring, because I'm just going to go through actually how a programmers work, okay, and how we look for resources when we're stuck, how we move on from there to complete our project. One of the things that I will be showcasing you guys is a very simple applications to a Twister dollar. Twister is actually a game. Are you guys, any of you familiar with Twister?
Yeah.
One. Wow. Okay, I'll show you the videos later on. Okay, you can try to solve this out. How many of you understand what's going on here? Okay, that's 1, 2, 3. Now, what happens is this, okay? I mean, programming is actually about, talking to the computer and trying to get the computer to do what you want to do. Initially, actually, I also wanted to go through the differences between coding and programming. Any of you does HTML?
Yeah.
Okay. When you do HTML, that is actually called coding. You're not really programming, even though it does involve some form of a language syntax. Because what happens is that, okay, you want bold print. What's bold print? in computer. It's your less than sign, b greater than sign. Or if you use CSS, there's a style that you use colon and quote. Okay, what you're doing is just that you're encoding what's in reality and trying to get it replicated in the computer. Now, when you're programming, it involves logic. Okay, that's a very, very subtle differences between coding and programming. So just get it over with. Now, when you're programming anything, pretty much on computers, so long as you have something that can just do plain text, and I'm not talking about your word processor. Word processor doesn't process in plain text. Okay, how do you know is it processing in plain text? When you open up a text of a Word document, and you try to actually let it display out in a command line environment, you'll find that there will be a lot of gibberish coming on around. Okay, because what happens is that all these words that you have typed in, like a word processor, actually has been encoded into a binary form. The reason they do that is because actually it's a lot more space saving, and you can do a lot more with binary versus just plain text. But when you're doing programming, you need to do everything in plain text because that's pretty much what the interpreter or the compiler will understand. Now, what is interpreter and compiler? Those are the things that that a language actually uses. A compiler language requires you to type out everything, your whole program, send it to this tiny little program called a compiler, which will convert your text into something that the machine can understand. Okay. An interpreter, on the other hand, you can think of it as a live interpreter of different languages. Say, for example, if someone speaks in English and requires me to interpret in Mandarin, okay, I can do that. It's an immediate feedback. So, if you're speaking English, I'll translate immediately in Mandarin to, say, someone that understands only in Mandarin. That's how interpreter works. It goes line by line. It's not like, you read through the whole thing, then translate the whole thing into machine language. So, to a certain effect, Python being an interpreter makes it easier actually to understand if there are certain things that you don't quite catch it. Like, say, if I want to understand a for loop, okay, in Python I can directly test it out. Okay, for something, is this how it works? But if I'm using, say, C++ or Java, I will have to type the whole program out, run it through a compiler, and then run the final binary that actually came out. Right? Okay, the importance of getting a proper text editor is that it actually helps you out with syntax highlighting. I mean, you can type everything, you want no biggie on that, really. I mean, so long as you use a text editor, but it does make your life a lot easier if you have a properly syntax highlight editor. And this is the one up. The next up really is what we call an integrated development environment. It's quite a long list. Now, what that does is that it gives you an environment whereby you can totally develop in a particular language or multiple of languages that makes your workflow a lot more smoother. Instead of switching between different windows and stuff like that, one IDE environment usually will take care of the whole workflow. Okay, say for example, if you're doing a lot of web stuff from your Python web server to your JavaScript, on the client side, server side, you probably want an IDE that can actually help you hold all this thing together instead of you manually switching between different windows and checking things out. Okay, how many people have I lost so far? You guys can understand what I'm saying? Good. What is listed here is the IDE environment. There are many different ones you can choose from, and many of them don't just tackle Python alone. It actually does a lot of different other languages as well. I mean, except for maybe idle is actually kind of like a pseudo ID, or should I say a multiple personality ID. It has an ID as well as an interpreter. If you guys fire up idle, which comes part of the Python environment, you see that the usual default when you start up the idle GUI is the interpreter environment. But then you can actually do a file new, and you see yourself in a editor environment. Have I lost you guys at IE? So far so good? Okay, so right now on default, on your station right now, other than idle, the other thing that you can use if you're on Windows machine is actually Notepad. Okay, but I would highly recommend if it's something better than Notepad called Notepad++. Okay. On the Windows, sorry, not Windows, on the Mac environment, I guess you can use the text editor. I think directly is different text editor. Okay. Now, a few things that you got to understand when you got yourself into a text editor environment. First off, you got to make sure that it is actually saving in UTF-8, not just in ASCII. Okay. What is UTF-8? Anybody knows?
Universal text format.
What does it do? All right.
No characters.
Okay, what happens is this. Computers don't understand human languages. When the computer was first being designed, they were being designed only for the English-speaking crowd. That's why when it first got designed, it's only using 7-bit. Okay, what does that mean? Computers only understand 0 and 1s. So you've got to somehow organize those 0 and 1s in a certain way that you can translate it back between the computer to the humans. Okay, so the human will type in, say, English text, but then all these things got to translate it back to the computer so the computer can understand, what to do. But then, before it spits back out things, you need to translate things back into human language form before it outputs to output device, be it a screen, printer, or any display devices. Okay. So what happened is that for a very, very long time, we've been using what we call the ASCII code. I won't get into the acronym of that, but just bear in mind something from America. It used to be 7-bit, 8-bit, but then later on, they discovered that, there's a whole world out there that don't just use English alone. We need to expand that. So come in two different groups actually, but those groups merged and finally came up with UTF. And UTF actually have UTF 8, 16, and 32. I think China is thinking of going to UTF 64. There's a separate issue. But just bear in mind that the most versatile one to use is actually UTF-8. And you need to make sure that your editor encoding is actually doing it in UTF-8. I'm going to give you an example here. This is my IDE is called Genius. If you guys are on Linux, this is actually a darn good one to use. Other than that, usually I'm using K from the KE environment. Because usually this kind of thing, once you set it up, you don't really think about it anymore. You see this? Default encoding. Okay? Most editors out there, their default encoding is actually ASCII. which is
West European.
you can see there's many different languages and stuff like that. For example, Western Europe. Well, sometimes it's called Western ISO 8859-1. Okay, it's either called ASCII or sometimes you'll list it down as this. But what you need to do is you got to make sure that your editor is being set to using UTF-8. Okay. Because with that, it actually encompasses not just totally many different languages of different countries. You also have different like your trademarks, icon, your registered icon and stuff like that. It's actually all inside there. Recently, I think even emoji was being inserted in the latest version of UTF-8. Okay, so you got to make sure you got that. There's actually another thing that you need to make sure of. Okay, the other thing you've got to make sure in your editor is that you need to set, not say you need, but I'm just going by convention here. I'll tell you about the GEP in a while. You need to make sure the width is 4. Most of the time, most tab spaces, they are being set to 8 spaces. Okay, so you need to make sure that this is 4 spaces, and your type is to use spaces only. Now what happens is this. Tab and space actually has 2 very different encodings. Internally in your computer, which most of the time you don't see it. In Python, everything it uses spaces. If you try to mix spaces and tab together, you're going to find yourself in some bugging hell. Okay, so to make things actually smoother in your Python editing, make sure that in your editor, you convert all the tabs into spaces. Don't mix them, don't try to do anything, just make sure everything is spaces. Okay, and by convention, 4 spaces for each tab.
Okay.
Have I lost anyone yet?
Yeah, on my editor it says soft tabs. Does that mean the same thing?
I don't think so. You can try. Usually, it's a very strict space.
It says tab length and there's soft tabs.
Soft tabs. It's the first time I'm encountering this. Usually, they just say either tab or space.
Alright.
Tab spaces. Right. Okay, so she just discovered, tab++. They actually have a check mark to say, replace tabs with spaces. So go through it. You've got to understand your editor. Everybody actually has different preferences for what's their favorite editor. Some people like Eclipse because it works with Java. Some people like the biggest level ever was like VI versus Emacs. Some people prefer VI, some people prefer Emacs. But regardless of this, whatever you're most comfortable with, just make sure that you at least have these things set up. So that when you save the time, the file is automatically a UTF-8 encoded file, and that all your tabs are actually spaces. Okay, you can see I have syntax highlighting here, but first is HTML file. Genie is actually a multi-language editor. So if I have a Python file here, you actually especially have a Python highlighted file. Okay, you can see from here, like certain things, like things in between quotes marks, it's going to be green in color. Things that are like part of the command is going to be blue in color. Stuff like that. It's much easier to read than just plain text. Okay, no quote highlighting. Okay. PEP8. Okay, PEP is literally a document where all Python developers look at when they are developing Python. Not developing a software in Python, but when they are developing Python itself. If things need to get changed in the Python language and stuff like that, it will be actually submitted as part of a PEP waiting for approval. Once it's approved, then it will be implemented. So this is like a documentation for Python. Okay, you have various different numbers, but for anyone that getting started with Python, is highly encouraged to read through this particular document. It's called a style guide. Okay. If you think of Python as a country that you like to visit, okay, PEP8 would be the do's and don'ts or the culture of Python. Okay, what you should do, what you should not do, what is highly encouraged that you do, stuff like that. Python in itself, actually, you can actually violate everything that this style guide has, and most of the time you can still work. Okay, but if you want to read other people's code and you want other people to be able to read your code, it's best that you stick with what this is being written on. Okay, so I highly recommend you guys read through this, digest it. Of course, if you have any questions, you can feel free to contact any members in the they'll be more than happy to help. Okay. Few things that we need to actually go through a bit here and there. Like I said, it's all written down here, but I'll fly through a bit and see how much I can get this covered. Indentation, tab spaces. Okay, you understand how in the IDE just I say, okay, please make sure everything is in spaces, and don't use tab. But if you use tab, make sure that your IDE editor converts your tab into with 4 spaces. There are people that use 2 spaces. I mean, that's fine and well. Like you say, Python will still run so long as you keep it consistent. Okay. Python is a language that actually utilizes space as part of its syntax. Okay. What you will find in many other languages is that they usually will use curly braces or parentheses or somehow or other to define a code block. Okay, what is a code block? It's a series of code that belongs to a particular function. I'll dig into that in a while. Okay. But with Python, the way to do it is that back up. Because even with those languages that we use curly braces or parentheses for code block, we still have to format it somehow using indentation. Why? It's to make the code human readable. Because seriously, in C and C++, for example, even in JavaScript, you can actually program your whole application to one line by using semicolon as a line separator. Okay, but in Python, that is not allowed. You have to actually use white spaces to make sure that this is actually belongs to this part of the statement. Okay, because it kind of makes sense to a certain degree. Even when we are programming C, C++, or Java or JavaScript, we will still have to indent it so that we can, as human, can easily read and understand. So why not just incorporate that into the language? So that's what Python did. Okay, and actually one of the reasons why Python, to read a Python programming file is actually a lot more easier than say trying to read some other languages. Okay, so those are tab and spaces. Maximum line length. Most of the time we are still trying to make sure everything is still back in the good old days of 79 characters. How many of you were born? I shouldn't say that. How many of you have used square monitors before? Before this HD long time? Okay.
Yeah.
Few of us. Okay, back in the early days when we had big fat square monitor, the amount of characters we can display is actually about 79 characters. Okay, so in a way, making things easier for old school codes and stuff like that. So they actually I highly recommend that each line of your code be no longer than 79 characters. It's also because the reason why another more practical reason why they're sticking with this is that most of the time we are not just opening one file. You can see some very seasoned Python application developers. They actually have like 6 or 9 terminals open up and they'll be looking at their code simultaneously. And by keeping to these 79 characters per screen, they can actually open multiple files up and take a look at it. And it also helps a lot when they are trying to see the differences between two versions of code. Because a lot of times, coders don't just sit on its own. I mean, it depends, but most companies will have a group of coders programming even the same file. So what happens is that, okay, a coder submitted a file into a Git repository and says, hey, check out my file. They'll check it out and then they'll look at it, okay, what's the difference between your old code and the new code? Okay, why are you doing this? It helps a lot with code comparisons, especially when you try to use, you guys see this line here? Okay, everybody see this line? I know it's very famous. This is kind of the guide that says, okay, you have reached, character 79 or you have reached 132 in our case. Okay, so when it goes, it will still go over, but you yourself as the coder or programmer, you know that, oh, you know what, I did this, I think I better split my code up so that other people can read it more easily. So it has like an invisible line, a line here to kind of like guide me to say that, okay, your code is too long. So you can set that up too. Of course, what's it independent of whatever. Okay. Tab, spaces, blank lines, source code file, I think went through all that. Imports. Okay, some of the things you can see that I will skip through because they are actually more for intermediate to advanced course. But to help you just get started, some of these things here will actually make more sense at least with getting started. Okay, different white spaces. These two code, when you read through this PEP, these two code actually will function. Most of this yes and no stuff will function, but it would be best if you can actually follow this because it helps with ease of reading. Okay, so I'm teaching you how to actually look through this whole thing. Okay, even for when you put certain coding this way, I mean you can do it, the non-recommended way. But when you look at, when someone look at your code which doesn't follow the PEP, it might get a bit confusing. Okay, you got a full sleeve of this. Like how you put spaces. Sometimes things doesn't quite work. Like for example, this. If you're using a function call, your parenthesis has to stick with it. You can see that other recommendations how to do things. Comments. Okay. There are block comments and there are inline comments. Block comments is usually we use like 3 double quotes or 3 single quotes, open end and the close end. When we need to actually explain things, a lot of times when we use block comments, we actually try to describe what the program does, which at the very beginning of code. Okay? Because even if you're programming alone, you'll find that 3 months later, or a few months later when you come back, or maybe something a few weeks later when you come back, you've totally forgotten how this thing is supposed to work, or how this is supposed to function. So comment is actually very, very important. You need to list down every single thing that you do. Mostly every single thing that you do. At least it makes sense that a few months later, when you come back, you yourself can understand it. You need to save parts to someone else to do it. Right? You have block comments, you have inline comments. Inline comments are comments that you put together with the code in the same line as the code. Okay? This is what we do for block comments. We use the triple quotation mark. And yeah, this is the line. We use a hashtag. Sometimes we may not use this, but for visual, how do you say, for visual impact, sometimes we use actually block, but we use multiple hashtag for each line, just to tell people that, okay, please, look at this is important. With syntax highlighting is much less of a problem, but with editors that doesn't have syntax highlighting, sometimes the hash mark makes it a lot more useful to draw attention. Okay, there's some version bookkeeping stuff here. Like I said, these are slightly more intermediate advanced stuff. Name conventions. Okay, we need to go through this. I'm going to describe this. Okay, think of it this way. You have, I don't know, tons of stuff at home, right? But you need to keep them organized, right? But then certain things, say for example, knives could be, say, belong to your, construction, hobby work. But then certain knives are supposed to belong to the kitchen, right? So you need to organize that somehow. Of course, with humans, you just write it down. Okay, knives for kitchen, knives for certain things. But in computers, languages and things like that, sometimes we need to compress the whole thing in order to make sense of how we organize stuff. Okay, and therefore there's a way that we actually recommend that how you name things. Most of the time, we'll name things with, say, just basic lowercase letter. Okay, if you need to use a uppercase letter, for pure uppercase letter, it's actually specifically being used for what we call a constant variable. Okay, what is a variable? I'll get that. I'll get it to you in a while. So most of the time we will name our things actually in lowercase. Sometimes we use camel case. What is camel case? That means you mix lowercase with, okay, say example, say for example, okay, say lowercase. Sometimes we use camel case whereby we say lower but with a capital letter C. The reason why we do that is so that we can actually directly see, oh, okay, this is a variable because the beginning is all lowercase. Okay, like I said, these are style guides. You can put everything uppercase, everything lowercase, mix upper lowercase as you please. But bear in mind that there's a difference as far as the computer comes up. A variable written this way and a variable with any changes in this is a totally different object altogether. Okay, so if you name something as capital letter A, it's totally different from something that you name as a lowercase a. Those are totally different things. Okay? In naming variables or classes and stuff like that, you do not start with a number. You can end with a number, you can put numbers in between, but you do not ever start with a number. You can start it with an underscore. Okay? But pretty much that's it. See, you have mixed case. These are what we call, the camel case. Capitalize words with underscores, you can do that. Underscore, I think, is the only symbols being allowed. They'll tell you about class naming. We won't get into class naming stuff because those get started to get into object-oriented, which is a lot more intermediate stuff. Global variables, function names, data methods, names, instances. I'm running through this, but bear in mind, just keep it at the back of your mind that these are some terminologies that sooner or later you get be familiar with. Constants. Constant usually we put capital letters all over. Designing inheritance, those are object-oriented stuff. Interface, programming representation. These are a little bit more intermediate, just naming your functions. Try an exception. Okay, so like I said, it's quite a long document to go through. If you find that sitting it through once and trying to sit through once and try to digest everything, it might be a bit overwhelming on the task. I mean, even for me, sometimes when I need to refer it back to see whether I should be doing this or that, it tends to get a bit of a headache when you go into things. There is actually a module that you can actually pump it in to see whether your code actually is PEP8 compliant. Okay. But like I said, I won't get into that yet. Alright, so this is the key stuff. Code start. Explicit code is better than implicit code. This one might be a bit intermediate. But literally what this one says is that, don't try to cover your bases by using this kind of a thing, because it kind of, how do you say, it makes debugging a bit difficult. Debugging means that, finding, what causes an error in code. It's better to be explicit. That means, spell it out. What do you actually require? And one statement per line. I mean, there are languages that try to do this, but in Python, you've got to do this instead. Okay, like say white lines and stuff like that. Okay, your condition 1, what to do, your condition 2, what to do. Calling a function and stuff like that. Okay, these are stuff that when you start getting serious into really programming everything, it's, like I said, another guy you need to look through. Okay, how you should comment your single line, inline comment and stuff like that. It's kind of like a repackaging of the PEP8, but with a lot more examples in us. Now, when you go into Google, if you need to know, you just need to type Python PEP8. Okay, you'll find the website for it, and several others as well. One of the recommended online resources that I highly recommend that you get yourself into is dive into Python. Okay, you can. Once again, you can Google it. This one I actually downloaded the whole website. There are tons of other resources. There's even nowadays a book called Teach Your Kids to Code, which actually uses Python 3 as well. And what that does was rather interesting. It's trying to use the Suzuki method of teaching. What Suzuki method does is that to have the parents and the child learn the language at the same time. So the child can literally mimic what the parents does and learn from them. For music, I know it works wonders. Not exactly sure how it works with language, especially when you need to explain things. But on the other hand, I read the book. It's rather fun. I got to add that. It's actually rather fun because it actually uses the Turtle logo programming language, which is built inside Python. Any of you heard of Turtle logo? No? Okay. Back in the 80s, this was kind of our first introduction to programming. Because what it does was that it has this tiny little triangle that they call it a turtle. And you're supposed to treat it as a very, kind of like a genius turtle whereby it knows how to draw. And this is the instructions. So you can tell the turtle to say, okay, pen down and then move 50 pixels. Okay, you pen down and move 50 pixels and you see a line. Then you can tell it to turn right move another 50 pixels. So you can tell it with a series of instructions. So with that, you can actually teach the kids to program by giving instructions to the turtle. So okay, when you do pen up to draw certain things, how you repeat, use the for loop and stuff like that. But for to explain this to kids, maybe even to adults, probably would be helpful. I'm not sure how many of you guys are actually into doing more graphical stuff versus what you can use in your work. Okay, so this is the book actually I very recommend. There's actually another online book, but it uses Python 2. It's called Learn Python the Hard Way. That one actually uses Python 2. That one actually, I would say, you have really got to be very patient to stick with it. I mean, it's a great book. I followed that instructions as well. But like I said, you've got to be really patient with yourself. Okay, because there are things sometimes that you don't quite get it, and there's bugs and errors, and you don't quite know how to solve it. It kind of get a bit frustrated. But then when you try to solve the bugs and errors, that's where you learn. Okay, another downstream implementation. How many sleeping already? I know all these are very dry stuff. Okay, but we need to get this over with. Most of you probably couldn't even remember 10% of it. Okay, been there, done that. Trust me. I know most of you couldn't remember 10% of it. Okay. Let's look at something a bit more interesting. I don't have sound. This is a twister game, okay? I hope the subtitles will do us good here. Okay, pretty much you need to get a referee. The referee will be the one will be spinning the spinner. Now you can see that the spinner actually has 4 colors. Go back. Okay. Okay, you see that there's a left foot, there's a right foot here, right hand, left hand. Okay. What I'm going to show you is that the process that most of us will be goes through actually when we program in Python. Right? We'll be actually programming this thing here instead of just a simple dice game, but the function pretty much is more or less the same thing. But this is a little bit more interesting because what happens is that at one point of a time, a cousin of mine does have this game, but he lost his phone. So very quickly, that was back in the 1990 something. So he's a VB programmer. So straight away he hooked up a VB code so that we can get this thing going and have our fun. Okay, so like I said, it's very quick to program. I mean, if you lost your dice, seriously, to do a straight-on dice game, dice function using Python is actually also very simple. But I won't go into the GUI stuff. GUI stuff is, how should I say, it's probably a lesson on its own. Okay, you guys just got started, so everything right now is going to be purely command line. Alright. And a little bit about GUI stuff is that Python 2 actually gives you a lot more GUI options, but how should I say this? I mean, the thing is that most of the things have now actually moved on to Python 3, and a couple of things actually are getting more and more Python 3 friendly. The languages that you can see, like most other absolute beginners book that try to use game to teach you how to program in Python. There's one called, I think, Python for absolute beginners, and even teach your kids to code in Python, and interactive Python, I think, for kids. They all uses this module called Pycon, which actually is not bad. It actually teaches the kids to program their own games. One downside is that both Pycon and there's another one we're supposed to so-called supersede is called Pycon. They are very likely in funding to actually move on further. Even when you visit their website, it's kind of sort of actually pretty deep. You know, so the thing is that for me right now, I'm using Kiwi language to program all my movies. Okay, and the nice thing with Kiwi is that you can actually program for mobile apps as well. So you can actually download the Android SDK, and with a few command line stuff, you can actually create the .app for the Android OS. iOS stuff I'm not so familiar with, but I saw the documentation that you can actually use the iOS SDK on the Mac itself to try to get Kiwi app compiled for an iOS device. Okay, so most of this book haven't actually really gone deep into Kiwi yet, but if you need to actually go into GUI app programming and stuff, Kiwi will be the one to look into. KIVY. Okay, so we'll be tackling this. So I need you guys to actually switch mode now from just absorbing what I've just thrown at you. Okay? To try to start thinking on how we're going to program our own twisted spinner. You got a question? No. Actually, how's everyone doing so far?
Okay.
Okay?
Yeah. You can do it. It's a random number.
What do you think we need? How are we going to do this?
Random number generator.
Okay.
Yeah.
We need something that can actually help us to random number.
Yeah.
Anyone else?
Oh,
How does this thing function? Think of it if you have this thing right in front of you.
well, we need two sets of data. One for the colors and the other for the anatomy.
Okay. Two sets of data.
Both of them are linked to random generators.
Alright. So we need something for the colors.
Try a new ones.
Okay.
Try
Let's
this.
try.
Try this one.
Okay. So we need something for the colors. And then we need something else for?
The left with right hand, right with the four.
Okay, you need your, what would you even call that? Hands and
Anatomy.
What would you even call that? Someone give me a name.
Anatomy.
Anatomy, I think, is the whole body.
Appendages.
Appendages? It's kind of long for a variable. Remember when you program, right? You'll be seeing that thing, you might even have to type that thing over and over and over again. you got to try to name it somehow that is least likely you make a spelling mistake.
Hand foot.
Certain IDE actually will help you out when you type your variable once. The second time you type something very similar, actually auto spell it out. That is actually also something very useful when you're looking at what editor you're picking for your environment. Okay, so you can bear that in mind. Okay, let's say hand and feet. Hand and foot.
Hand foot.
Or hand foot. Okay, these two are how we're going to name, the kind of choices that we have. But notice something though. The colors are fixed.
Yeah.
Okay? Your left foot, right hand, these are fixed. They don't change. The only kind of changes is where this thing points. Right? So, by the PEP guideline, when we have a constant variable, you do not write them this way. You write them in all caps. So, literally, this one will have to be like this. Okay? Here's the thing though. How are we going to represent this? Let's just strictly talk about, representing the colors, representing the food. You can see we got, 4 colors and we have 4 hand food. How are we going to do this? If you remember that, I said that you cannot put numbers in front of your variables, but you can put it behind, right? So, most beginners, when they first started, not knowing any better, they most likely will do this. Color 1, then you have, color 2, so on and so forth. Some of them will actually try to do color red, which is a bit more descriptive. Okay, and you have color blue, and so on and so forth. For your hand foot, you got hand foot, left hand foot, right, so on, so forth. Okay, but you'll find that there's an issue with this. How is the random generator going to pick, whether you use color 1, color 2, and things like that? Random number generators only generate numbers. Okay? And in this particular case, we won't be actually just generating any numbers, we'll be generating only integers, positive integers. Okay? And you can see from the numbers that we have, we actually got to generate how many numbers? 1, 2, 3, 4, done. 4. We can generate 16 numbers. Now whether we generate 8 numbers by 8 numbers, that's a choice. Okay? If you really wanted to, we can encode the whole thing depending on how we like to encode it to generate 16 numbers. Have I lost you in math? How many of you here actually is purely visual arts person? Okay, don't be shy, it's okay. Because like I said, most of the people that I coach are actually visual arts persons. They hate to deal with language and math, but they finally still be able to do all the stuff. Okay. So, I'm going to introduce you to two concepts now. Okay, two data types. Okay, three. So we have got colors to deal with, we got this hand and foot to deal with, right? We can actually put the whole thing into what we call a list. This is a kind of a data type in Python. Now inside the list, you can put in other data types as well. You can even mix different data types, but it's not recommended. Okay, reasons is more of humans tend to mix errors if you actually start using things separately. So keep it consistent. You put in a certain type in there, just keep it there. So how are we going to do this? In a list. Is it better to actually put the list using numbers? Or is it better to actually put the list using text? Or in terminology that we speak of in strings? Which is better? Anyone? Strings. Okay. But if you put it in strings, how is a random number generator going to call a text? Using the index of the list. Okay. So what happens here? You can call it, the color. Open brackets is how you actually create a list. If for you guys that come from C++ background, if you really have to, you can actually declare it as a list open close bracket. Okay. Then you have a whole slew of methods and methods that you can use to do this. Because everything in Python actually is an object. Okay, an object will come with a series of methods that you can use. I know I'm probably getting ahead of myself. Some of you guys who are not familiar with it will be wondering, what the heck is an object? Okay. Without going too much into details, think of it this way, okay? Like I said, anything is an object. So let's think of this pen. Okay, this pen is an object. It's a pen object. But what kind of a pen is this? Okay, you can put in a description. It says it's a whiteboard marker, right? Then what kind of methods does this whiteboard marker has? It has non-permanent ink. This is one method, so that you can erase it away. Okay, it can write. Okay. Yeah. Right. Think of it that there are things that an object can do. Okay, so later part we'll look at different things that you can do with things. But like I said, I'll be using object quite often because the nature of the language itself is very object oriented. Okay, but just bear in mind that there's this concept brewing. For more intermediate stuff, I think how many of you actually attended the earlier class? You attended the earlier class, okay. If you're not familiar with, it might be a bit advanced when you go through the earlier class because they start using class and then start describing objects and stuff like that. Those are actually more intermediate language concepts. Yeah, but just bear in mind here that there's things you can play with when you declare something. Right? So we have what red, green, yellow, blue. I'm just going to go shorthand here. You guys can do it however you like. Okay, and hand foot, we can just say, hand foot. And then we can even declare left, right. Or you can even declare left hand, left foot, right hand, right foot. Okay, let's do that instead. It'll be easier. Say we have left hand, right hand, left foot. Everybody so far so good? So what now? We have all these things being declared.
What we say, like an offer.
Okay.
Here's the thing that Python actually has done for you when you put things in a list. It actually has indexes for you to actually get to it. And the way Python counts is it counts from 0. It don't count from 1. Okay? So literally each one of this, including this, start from 0, 1, 2, 3. Okay. So in order for you to actually get to, say, RH, okay, right hand, get it to print right hand, you actually got to note it as okay, when you type this in, it will spit out for you. Okay, notice that I haven't get you guys to actually open up your Python CLI and whatnot yet. Okay, reasons is because most of the time we don't even open up anything yet until we actually have the pseudocode done up. What is the pseudocode? You'll see it in a moment. Okay, it's actually kind of an English-like statements that you go through to think of, okay, what are the steps I need to do? Think of it that, instructions that you give to kids when you need them to do things very specifically. Okay, I know I've got 3 kids myself. So sometimes, they don't exactly follow, actually not say exactly follow, they don't follow what you imply, but what you explicitly tell them to. Okay, so you got to say, okay, step 1, pick up the blanket. Step 2, fold the blankets in half, getting corners to corners, getting the adjacent corners, okay, then you fold it, so on and so forth. Those are the things that you need to actually write down the steps to think of how we're going to do this. Okay, everybody clear on this part, right? We define our stuff here. We know how to get to this. So, are we going to program this thing now? First thing first, you see that there's going to be a user using this, right? The user needs to spin this thing. So that means that we need some form of a user input. Okay, whether it's a mouse click, keyboard typing something, a touch device touching the spin button. Okay, we need some form of a user input. Okay. Oh, but you know what? I keep forgotten how to do the user input. So what can I do? You look up documentation. Documentation, you can actually go through, like I said, I use, written documentation like that with Python. You can use, various documentation they find. You can Google it, how to do the input. Most of the time, you probably need to do some Stack Exchange website.
Stack Overflow.
Stack Exchange, Stack Overflow. Let's try to do something. You can try to use help inside Python itself. Now, say I look at it and say, okay, kind of sort of makes sense. I refer to a few things. Usually the website is a lot more helpful than what you have over here. Okay, but at least with this, it gets you started looking right. I have, Okay? I mean, I've been programmed before. I've been programmed before, yeah. Programmed, a few times. I kind of remember saying, okay, they think you need a variable maybe. Oh, sorry. This button, please. This, in a way, is the power of the interpreter. When you find something that you don't know and you want to test it real quick, fire out the Python interpreter, start typing it in, see whether you understood what is being said or whether you got the syntax correct. Okay? So far, so good? So, okay, yeah, we've got, press a key, great. So at least we know how to get user input. So what next? I know how to get user input now. So let's start to think. After the user input something, in this case it could be just press any key, or just press the enter key. Okay, so we know user input. So first thing first, we're going to say, okay, let's say user input. What should we do next after user input? Spin. Okay. Let's just say we go to spin. What should we call this? Spin. Let's call this the dice. Take note that we haven't really defined out this method. But we do know that after a user types something, we're supposed to call this. Okay, very likely, very likely, this is going to be a function. Does anybody need me to explain what a function is? There's no.
You want single task.
Sorry.
You want single task.
No, we're not going to do it.
No, unique task.
What?
Unique task.
You want unique task? Okay, got it. Yes.
But most of the time, you would like to think that we are doing one unique task. But I do know programmers, sometimes they try to take shortcut. They try to program one function. Not a good idea because the big testing and debugging actually is not more tricky. Okay, but this one says is the things that is called each function should only do one and only one thing.
Sharpie.
Okay. So okay, we know we have Mr. Dice. What is this supposed to give us? It should give us a
Hand and color and part.
It should give us this whole chunk. Okay, it should give us an end result. Blue, black, and okay, in this case, right? So we need to know. We know that okay, this thing. We also want to write a pseudocode for this. Each function, method, whatever that you need to be programmed, you're going to have a pseudocode so that you can see exactly what each code does. As you program, you are a bit more advanced. Sometimes, even I know a lot of programmers who actually start writing code already, even on just one code. It may not be properly syntax code, it just needs to be humanly understood. Okay, a human can understand it. It doesn't have to be syntactically correct. Okay, so we need to figure out twisted dice in a while. Okay, so it's supposed to give us some form of a result. What kind of result do we expect then? Should we expect LR, what do you call that, B? Or should we expect left hand blue?
Left hand blue or more
Left hand blue,
readable.
right? Makes more sense. Okay, now, if you think about it, just now I was using very shorthand code, LR, LH and stuff like that. So now it's time for you to rethink, okay, is there such a good thing? Because when I grab the item out from my list, it's going to show LH, not left hand. Okay, so you got to think about all these things when you code. How's the output going to be? Is it going to be relevant? Can I make things easier for myself as well as the user, not just for the user? Can a change in the way you name things or in the way you write things be helpful to you as well as your fellow programmers? All these things you're going to take into consideration. Right? Okay, so, for lack of what here, think back, okay, later on when we program, we're going to make sure that our list, we change it to a properly named left hand. It's up to you, you may want to call left hand, in one word, as one word without space. Or you can call it left hand as separate word and, do your display in a different form. Okay. So we need to give the result and say we prefer to do it like, say the screen printout. It's going to be, so this is the output that we want. How you see your output is also something what we call user experience designers and things that actually takes into account. Embarrassingly, unfortunately, most coders, programmers are actually not very good UI guys. I've worked with so many people that they just plain suck, including me. I have to admit that, I'm sorry. Okay, so a lot of times what we do is that we actually get a user experience person, a designer, to actually design the whole user experience to see, okay, how this thing should relate, how this thing should look, and then throw it back at all the coders and the programmers. Okay, how are we gonna do that? Right? I got to say that when I first had to work this way, it wasn't easy because a lot of times what we think was what we take for granted that the user should know it. The end user actually doesn't know it. So in the end, when you follow the UX designers, the way interaction should occur, it actually works a lot better. So, like I said, whatever the UX says is pretty much how do you say, is kind of like you got to follow. Okay. For right now, of course, we are not exactly getting into that. Most of the stuff are all command line. But at least right now, we'll say, okay, the user should see left and blue on this command line whenever we press save and enter key. Okay. So we know this. Okay. Are we done? No. We're not done yet. We still have to figure this out. How should twisted dice look like?
In a few minutes, you guys are going to break for lunch. But I need you guys to keep in mind, okay? All this code later on will be programming in. Okay? So next thing that we need to figure out is crystallize. We know we need to generate random numbers. Okay? And we have already split the two up into two different random numbers. But the nice thing with it is that, the two parts to be split, they are all four constant. So literally, if you think of it, we can actually simplify it. I'm actually jumping quite a bit here. So we can actually generate a random generator that will pick from 0 to 4 twice. Okay. Some folks will go all the way to actually, do a separate random generators. But for me right now, I would say that we will have a variable. Let's say our variable is called result and put and a result what do we call colors? And with this, we do a random, for the random integer from 0 to 4. Okay? Same thing here. We're going to call the same exact thing. Integer from 0 to 3. Remember, there's no third index. We have 4 objects, but they're made from 0 to that. Okay. Then after that, we're supposed to return the result, right? So far, so good. Okay. Like I said, I'm stepping you guys through on actually how programmers actually has a function. Literally, for this whole thing to happen, for the past 2 hours, 1.5, 2 hours that I'm going through, we literally do this in less than half an hour, sometimes 10 minutes. For this kind of program, probably can write it in half an hour.
Yeah.
Including all this stuff in half an hour. But like I said, this is for absolute beginners. If you guys already have your previous languages and things like that, it's not exactly a class for you. But I'm stepping it through for those that have never had before. We can say we are actually almost done with all the pseudocode. Okay, the rest of it really is to straighten out and how we're going to get the strings together, whereby we start looking into how we're going to program this code. Okay, just keep in mind all the things that we discussed. Later we're going to translate all this pseudocode into actual code. Okay, we will see how we can actually do it live, as well as how we're going to code it in your head. Initially, my intention was actually to have you guys take off a program that you wish to write that will actually somehow rather relate to your work. Okay, but I'm not sure if we have the time to do that. If we can, actually all the more better. Okay, and I'll go by individually to see how I can do this. But that was the original intention. Okay, whether we have time to do that or not, we'll see how we can work it. Because ultimately, what I'd like you guys to leave with is that you can go back home and actually be comfortable in open up an editor or in Python command line interface and start playing with it and start working with small code. Okay, like I said, this thing, we solve the issue. We have a problem. We solve the issue with programming. It's something simple, something easy. a lot of times at work where I do animation Python previously. Most of the time we are doing a lot of Python people. We look at it and say, hey, this program is doing this thing again and again and again and again. The moment something repeats constantly and the pattern, you can literally see the pattern evolve. You can actually translate that whole action into a program that will speed up the process for the end. When they need to do certain calculations or to see certain results. Right? Right. I think the break should be really implementation to this time. So go ahead and have the break first. We'll come back to this. You guys go back to the
Yeah.
2 o'clock, right? 2:15. Okay. Yeah, go ahead.
And the workshop is supposed to end at 8:30, so we like to start now. First, I'd like to have a few announcements before we pass on to Xiangde from our ultimate sponsor on app. Right, so first announcement is toilets are downstairs, so you need to go to the toilet during the break. It's downstairs near the main door on the right side. Okay, so it's on ground floor, main door, right side. Second announcement, staff members easily identifiable, but they have this red armband and also red lanyard. So if you have any issues, you have problems, you have questions, you can find one of us. Please wear your lanyards all the time so we know you are participant for Pycon Malaysia. And I'd like to introduce myself first. My name is Iqbal, I'm the chair, Swimming is my co-chair, and Ras is handling our t-shirts and swag and everything else, and catering, right? So if you have your guidebook app, then basically everything's inside there. We'll be updating that constantly when we have changes. So please refer to that frequently, and basically that's it. So the rest will come, I guess, later on. We have another workshop session after this by Victor. Victor is already there behind us. And then tomorrow we'll have the conference day 1 and then Sunday day 2. Okay? Alright. Thank you, Senator. Okay. All yours.
Yeah,
Wi-Fi. One last thing, Wi-Fi is very important. Okay, so there's Wi-Fi available. It's called student, but there's no password. Sometimes it's on, sometimes it's not. So right now it's not online, I think. But it was like 10 minutes ago, so just be patient. Staff can be used. Staff can be used. Okay, yeah. It's either you have a student or you have staff, right? Okay, right?
Can you the light off or
this one good enough. So hi, I'm Sienna.
Yeah.
I will do a brief introduction of myself later. I just want to do a quick survey. I saw 2 Macs and I think I saw 3 Windows.
Yeah, I just disconnected from the Wi-Fi.
Oh, sorry, 3 Macs. And so, can I know whether for the Windows, have you downloaded follow the instruction that I provided?
3.4.
Yes, 3.4.3. Cool. How about you? Oh, not yet. Okay, maybe you need to follow the instruction. I'm not sure how fast is the connection here, but we can try. And okay, you can switch on the you can switch on okay. So can I know how many of you use Python weekly?
Not really. Not really.
Monthly?
Around
Yearly?
monthly, bi-monthly.
Okay, I just want to have a brief understanding lah. How many of you use Python 2.x? Okay, 2. Then the rest all use 3. Really? Huh? Or Ruby?
3.
Oh, okay. Because 2 and 3 quite a bit of difference. And so the reason why I chose 3 is because the next workshop is 3. So I use 3. Just to unify a bit, right? So in this case, who is in development? May I know? means you write software
Yeah, sort of.
weekly. Okay, 1, 2, 3, 4. Cool. May I know what language you use weekly? Ruby, right? I heard. Java. Okay. Qt. Oh, cool.
HTML5.
HTML5.
Just PHP, HTML5, jQuery, all those stuff.
Python. Oh, cool. Okay, so we have a guru here. And the rest, may I know where are you from? Are you from UM or you're from? I saw one is from education industry. And may I know where you from? For development. What language? PHP. Cool. Okay. Who else I haven't heard? How about you? UN? No. U10. Okay, cool. How about you? Same, education.
Hospital.
Oh, hospital.
Healthcare.
Oh, healthcare. Okay, cool.
UH.
So, based on the feedback of everyone, I think we'll go simple. Sorry to the other guy. We go simple. And so, topic of today, the workshop is quality of life through unit testing. And it's something very simple. And we can learn Python 3 together so that later on you can proceed to the next workshop. And so we wish to accomplish 3 things today. First is to understand what is unit test. Second is to practice. And third, if we have enough time, depends on your environment, we can also try to play around with things lah. And lastly, the third part is just some elaboration of what we can do. But we won't be doing it today. So for those who haven't cloned the repo, you can clone the repo. You can also get this link from guidebook for Pycon's guidebook. May I know how many of you use before Vagrant? One. Okay, cool. So generally, why I provided this Vagrant is because everyone runs on different environment. So it may be easier if we use it on a virtual machine. So that's the reason why we suggested using Vagrant. So let me introduce myself. This is my name. I'm Senla. You can call me Senla. And I work in ONAP. Happens to be the sponsor for this, platinum sponsor for this event. I'm not the sponsor, I'm just working for this company. Just now someone said, oh, you are the sponsor. Not really lah. And I also involved with CINAR, even though I do very minimal things, but usually what I do is I tell people about this group of people called CINAR Project. So I encourage you to visit this website called cinarproject.org. They do wonderful things. And lastly, I used to work in Utah for 7 years teaching before I joined IT industry. So that's my brief background. If you want to know more about me, you can check out my LinkedIn. Oh, so maybe you want to know what I do as my daily job or my weekly task. So ONAP is a company that does software for hosting companies and for telcos, where we do cloud software, we do CDN delivery and so forth. And Python is one of our main language, where we use Python to write scripts to actually generate all the configuration for all the servers that we manage. Currently, we manage about 400 plus servers, and Python is a very useful tool to actually help us to achieve this purpose. Now, of course, we use Java too, and Ruby is our front end, and PHP used to be our front end, and it still has some legacy running on PHP. So let's look at unit tests. May I know how many of you practices unit testing?
Rarely.
Okay. How many of you heard before unit testing? Cool. Okay. So based on things that you heard, do you find that unit testing is hassle, problematic, or waste of time, or it takes more than what you need to do to achieve a job? Perhaps sometimes some people may give you that type of feedback, because unit testing, most likely you need to write extra codes. And some people will say that if I want to, a common feedback from developers, they will say that if I want to do unit testing, let's say I need to finish this task, this application, in let's say 2 days. I may need 1 more day to write the test, and it's a waste of time. It's a very common feedback from developers. But actually, it's on the contrary, it's very different. Where if we write unit tests correctly, it actually helps us to push the product faster, because our product has less errors, has less issues, or we call regression to a certain extent. So maybe you want to first understand the definition of unit testing, whereby if we use the word test, it's as simple as testing our code in that sense, right? But why do we use the word unit? Is some reasons. But before that, I want to come to this slide where I want to define the topic of this workshop. Quality of life is determined by quality of code. I'm not sure whether you agree or not, but to me, I always find that my quality of my own life, the 8 hours in office, and also the other remaining hours somewhere else, is always affected by the quality of code that I work daily. Because if the code is properly written, if the code has less bugs, if the code is so much well performed in that sense, then it's pretty easy for me to continue my task, right? But let's say it's given a piece of code that maybe it requires me 1 hour to actually understand that maybe 100 lines of code. That is very, very painful. So, quality of life is determined by quality of code. The reason is because quality of my life and your life is determined by the quality of the code that I and you work on. And from a greater perspective, quality of life of one, which is me and you, is determined by the quality of code of someone else wrote. Alright? So it's actually pretty important for us to write some codes that is easy for other people to continue their work. It's just like reading doctors. I don't know why we always prejudice against doctors, but we always have this saying that if you read doctors' handwriting, it's really horrible, terrible, and whatsoever, right? I'm not sure whether you agree or not, but if you read my handwriting, perhaps you say you're a horrible person. But that's a reality that when we read someone's code, it can be horrible at times. So, unit testing helps us to achieve better quality of code and improve our life. And let's look at the definition of unit. So over here, it mentions 2 things that I highlighted, whereby first keyword is called single, and not multiple. And after that, the next thing is to verify. Okay, I sum up this entire paragraph in actually just a sentence, 2 sentences, with 2 keywords, single and also verifiable. Of course, there could be an expansion of this theory or whatsoever, but we just focus on these 2 keywords, single and verifiable. So, writing tests that is supposedly called unit tests is trying to test on one thing, right? Single. And then verifiable, because we test. So we want to verify the feature. As simple as that. Of course, if we expand the theory in details, we can see that the word single doesn't mean one thing. It can be a chain of things that achieve one functional thing. that is the second they're trying to explain. But that's not important yet at this moment. So if you're interested to explore more about the definition of unit test, there's quite a good book that explains about this. But the book used C# as an example. It's by this guy. The book is called The Art of Unit Tests. Then we have a whole long list of theories. And these theories you can get from a book or you can get from the website also. Because I can tell you the truth, I copied from the website. So if you want to know more, you can read it out. I also will provide you the slides later on in the GitHub. So you can have the link. It's a Google Doc or PDF format. You can just download it if you want to refer to it. In general, over here, it just tell you what's a good practices, what determines a good unit test. Alright? To keep it simple, it helps us to verify things. We like it, right? We like simple things. So we sum all this up, become one. It helps us verify things. So now we come to practicing unit testing. So I want to work together with you in writing a very simple program. I've been thinking a lot about what to write, and I think easiest is to write a very simple program called the calculator program. So let's go back to primary school days. When we talk about calculators, usually we only imagine or we'll be able to visualize only 4 operations, correct? And the operations are multiplication, addition, subtraction, and division, correct? So I didn't pass primary school. So, I guess most of you already have your environment up, so you have Python 3. So today we'll do Python 3 way. If you only have the Python 2 terminal, of course you can use Python 2. But there will be a bit of code difference lah. Okay. So now we want to start a very simple program called calculator.
Do you guys need the light off?
Yes, it's okay.
So if you have cloned the repo, in the repo you should see several folders, and after you run after you ran for the first time, Vagrant up, you get extra 2 folders, I think, right? Let me just explain to you what you need to know. First, if you want solutions, you want answers, I've done it, and it's available in the source folder. Alright? So you can go home and try it out yourself. And today we will go to the other folder, which is the practice folder, where we will write the code together in Python 3. Alright? So we go to practice. So here you can see we have 3 files and 1 folder. And if you open up the files, it should be empty lah. Okay? So we open up the calculator file and we start writing the calculator class. It will be very simple. First we define the class, then we name it as calculator. Cool? Then after that, just now we already mentioned, you are very smart, not like me. You know there are 4 basic operations. Therefore we define the functions. So the first function is f. Because it's a class method, we always point the first argument for every single function with the class pointer itself. So we use self. Then after that, we also know that if we want to use addition, most likely it involves minimum 2 numbers, correct? So we try to keep it simple. We just put number 1, number 2. Yeah, man? Yeah. So simple, right? So the next thing. So if a person gives you 2 numbers, what should you return? The summation of the 2 numbers, correct? So big simple program. Okay, after that we continue with the rest. the font too small, or do you need me to enlarge it?
Is the indentation important?
Sorry?
Is the indentation important?
Yes.
It is.
Yes.
Okay.
Python, if you notice, Python don't have curly brackets, right?
Yeah.
So they use indentation to do the blocks.
Some trouble.
The things that I'm going to do, or some certain tricks, usually can be done terminal based. Therefore, for Windows PowerShell, I'm not sure how it interacts with Python, so I'm sorry, I'm not sure. But those Macs and any Linux based or Ubuntu based, the steps should be similar.
Use
I'm going to do it. Okay. So for those Windows one, maybe you can try to have a look. You can type the codes, but in terms of testing the code, you can look on screen as I show you how to do it. So now you just write a simple calculator class in Python. I may try to write it in 2.7 so that Python 2.7 so that most of your PCs will work.
Yeah, because
I will tell you when there's a need now or when there are errors, I can try to fix it for you. Alright? So, so this is a calculator.py class, and usually I'm a very particular person. I'll try to write something extra, which is
comment.
oh yeah, comment is very important. But we have something like this in Python 2. Is something we call constructor in Java, in a way, right? So you can do that. Okay.
I think those people who don't have this can use Sublime Text.
Yes, yes. Yeah,
Because
some of them are using something.
It also puts in the correct indentation.
Any text editor will do.
Yeah, but the others you have to like tab, and all those things.
Maybe. So we'll try to fix it later. So, okay, so the next thing we want to do is actually write a unit test because we have wrote a piece of code. My gut feeling is working because it really takes simple right now. But let's say we wrote something more complex. We want to test it out. The only way you can test it out without writing test cases is running the program itself, right?
Yeah.
But one of the better ways is actually by writing unit tests, where we test every single functional unit in that sense. So in this case, we're going to have at least 4. So those want to use PC username password is here. So I can't remember where I stopped. Okay, so now we want to write the test, and over here, since we define the unit test is actually single functional unit or single unit in a sense. So here we have 4 units we can test against. One is addition, one is subtraction, multiplication, and division. Alright? So you can so in the practice folder, we have another folder called test. So let's go into the test folder. And we have I've created a file called calculator_test.py. Inside should be empty. Okay? So let's open the file. And we start writing test. So Python is something similar with your C or your Java, where other than the codes that you write yourself, you also can import so-called libraries. In Python we call modules. So since we are writing unit tests, Python 3. Okay, so Python 3 has a standard library for unit testing. Python 2 not. Only mock don't have. Okay, so okay, that's still safe. So let's import unit tests. So that's the module for unit tests. And after that, we want to write a class because we want to test. So maybe we just call test calculator.
I'm sorry, which file is this again?
Calculator test.py.
Alright. Yep.
In the test folder.
Alright, thank you.
Okay, the next thing you want to do is that this test class will be, if you have write in Java or something else, our classes can be extended or can be inherited from another class, right? So in this case, our test calculator will inherit from unit test case. So you may be asking, how do I know whether this module got this particular thing called test case or not? There's a trick to it. So it's part of my slide. I can show you also. In practice, what you can do is actually in your Python terminal, you can actually import unit tests. Okay, import unit tests. Then after that, you can actually use this thing called dir unit tests. You can see a whole bunch of things, right? And you'll be able to see test case somewhere.
Yep.
Here. Okay? So this is one of the ways if you want to do it manually without Googling or without going to the manual. Sometimes you cannot remember. People like me, I have bad memory. But a quick way to find out is using this command. Okay, so let's come back here. So we want to write a test case. And in unit testing, usually we have two standard method. We call setup and also head out. So in Python, if you have nothing to write for that particular method, usually you just put pass there, the keyword pass. So let's write the first test case. We call test add. And just now we have written a class called calculator, right? No? And since the file name is called calculator, so what we need to do is from calculator, the file name, import the class name, calculator. Okay, from the file name, import the class name. So over here we can instantiate the object of calculator, where we can say C equals to calculator. Okay. Okay, after that, we can try C and let's say 1 and 2. And by gut feeling, when you run this method add 1, 2, usually you get what as a result? 3, right? Okay, if you're not confident, you think I cheat you, you can check back at your code. That's what your code does, right? Not? Where you add the first number and the second number, you get the summation. Okay? So, the next trick I want to show you is that usually before we want to assert, maybe we are unsure of the behavior of the code. So perhaps we want to run the test first. Maybe we want to print out the result. So we can try to print the result first by cheating. Unconventional but useful. Okay, we can try to print first. This is Python 3. Python 2 should be okay also. Using bracket. Okay, the next step I'm going to show you applies to non-Windows environment. So sorry, where we can actually use the trick to try to run the unit test again and again without keep running the command manually. So we use a command called watch. But before we use that particular command watch, maybe you want to run the unit test one time first. So I'm pretty sure you are aware that if you want to write a Python program without putting something on top, you can just run Python, the file name, right? Not?
Yeah.
Okay. So We first run this one. Then after that, it says no module name calculator. Okay, so this is a very common Python thing where because the Python path was not set correctly. Because your current folder, you import calculator, Python not sure where is your calculator file, or the module in that sense. So what we need to do is we need to set the Python path. Because currently I'm in the correct folder, which is practice, I just need to put Python path equals to the current directory, and then I run the file. Okay. Then after that, you see, hey, empty one, oh. Okay. So we successfully run the file, successfully import calculator, but yet we see nothing. Therefore, something is wrong, right? No? So what happened is actually over on the unit test file, test calculator, we need to make it executable in a way where we need to set if name is main, then we run the test. Okay? So if we run the command again, we will see over here, ran one test in close to 0 seconds, which is okay. So there's no test fail in that sense, right? And if you notice, there's an output here called 3. That is the expected output right now. Okay, yeah. So the next thing will be, it's troublesome, right? I have to keep pressing this command to see whether I get the right result or not. So there's a trick, a cheat, where we just use watch. I usually put 2 seconds and I run it. So you auto refresh, making the call every 2 seconds. Alright? Okay, now we come back to the code. Just now we use print, which we don't really need to do it because we are just curious of the actual result. So when we want to write a unit test, we want to validate results, we don't use eyeball. We use the unit test module to do the checking for us. And the validation of the checking, there's a term for it called assertion. Okay, assertion. Yeah. So we can put self assert equal comma. Let's say I put a wrong value first. I want to see whether 3 is the correct value. So sorry. Let's say I put 5. Okay? So I want to see the output of this particular execution, whether is it 5 or not. In this case, you should know 3 and 5 is the same. Not the same, right? So we can see over this side, when you run that test file, they will complain. And what they complain, they say assertion error, means the validation, something went wrong. Where 3 is not equal to 5. Alright? So as simple as that. So now what we need to do is we just need to change the value to the correct value. Then after that on the right side, because it's running every 2 seconds, you see the result rate where the test is. Okay, no problem. So usually this is how we do very simple unit testing, where we try to see whether the output is what we expected. In this case, we are checking one single thing, which is the addition function, whether is it working correctly or as expected or not. Right? So of course, we can continue by adding more. The one you can do yourself at home if you want to. There's one common practice is that, let's say I want to have the next one, test subtraction. Maybe I need to put calculator again, right? Not? So that is a bit troublesome because I need to create a new object every time where I go into a different method, test method. So what usually we can do is we move this instantiation of this object to setup. Because setup is ran for every single test case. In this case, test case is equivalent to the test method. So what we can do is, in setup, we put self C equals to calculator. So over here, we don't need the line. We just need to do something. So after I save it, over here, there's a total of 2 test cases, 2 test methods, and it's confirmed that 2 tests, okay, no problem. And is it okay?
Yeah. But the Mac doesn't have a watch.
Oh, Mac doesn't have watch.
I think so.
Homebrew can help you install watch.
Alright.
So if you want to do Python yourself and stuff like that, you can use UM's desktop, and after that install a software called Raven. Then after that you can run the Linux environment. Yeah, I mean, if those who are stuck and can't proceed.
Alright. It's not working. Can only look her.
Arguments, see whether they are the same or not. But actually there's a third parameter. So how do we know that? Because first you can Google and you can get the thing, right? You can Google and check about see what it is inside. Another way we call inspect. So in your Python terminal, you can import inspect, and after that, you can so we can inspect again, inspect. Sorry, we need to import. Okay, so there's this command called inspect dot get mark spec, means get argument spec specification, and then you list down the exact thing you want to know. And you will see the aspect where you can see that the first, second, which is the first two values that you compare, and the third part is actually the message itself. My things here got jumbled because I resized my terminal. So the command is this one. So you can inspect, get upspec, the thing that you want to know, the methods. And after that, it show you the method except what arguments. So this one you also can get it from the Python doc itself. Sometimes we lazy, want it faster, you can do this way. So based on this, you can see that over here, we can actually insert the third argument. We can put a message. Let's say hello Pycon. And of course, now we won't see anything because the test is positive. Therefore, they don't throw any error message. Let's say I change the value of 3. 1 plus 2 is 3, but maybe I put 5. Then after that, you can see that the unit test will complain, and then it will give you an assertion error. Why is it error? And after that, they give you a customized error message. So you can actually insert your customized error message. Okay, so the next thing we want to do is that, because I'm looking at the environments, perhaps we have some issues with doing in practice. So I'm going to change the mode a bit, where I'm going to show you how we write tests based on the codes that I've written in terms of counting.py and also calculator.py. Yeah. We will write separate unit tests for it. At the same time, I encourage you to switch on the UN desktop and you can install Vagrant. so that your next session at least you have a working machine to actually do your coding. Okay, so now I go to the other folder, the folder called the source folder. So the repo that you've downloaded, inside there's a source folder, inside has all the answers. So we go to the source folder, it has the same structure, the calculator.py, calculator.py, and inside has a test folder. If you look at the calculator.py, it has all the complete codes that I plan to do. I just explained to you the code structure, so at least you can understand what is it. So it's the same thing, we have a calculator class, and after that you can see this thing here. It's actually a comment, multi-line comment. So we use 3 double quotation or 3 single quotation, which is also fine, to start with multi-line comment. And after that, we have the same thing that we did just now. And the only changes that I made is to the division. Over here, I did some customization to the division code. Where we want to capture something funny. Because usually if you notice division by 0, you get, you can't really divide by 0, correct? So in this case, maybe you want to give some customized exception or customized message in a sense. By default, Python will throw an exception called 0 division error. We can do something else. So it's pretty simple. The division, before we perform any operation, we actually check whether the second number, the number to be second number cannot be anything, if it's 0, then we raise the exception. So this is how we do it in the Python way. And there's a way for us to test it out. So over here, like just now we have done this part where we set calculator to the instance variable, and after that we have test n. So we first check whether 1 plus 2 is it 3 or not. So it's correct one. Then after that 1 minus 2 should be minus 1. Multiplication 1 times 2. So you get 2. Then division. Here, we have something different. Where in Python 3 and Python 2, there's a different behavior. Where 1 divided by 2, in Python 3 we'll get 0.5. But in Python 2, point something, and before, you'll get 0. Okay, so the behavior is something like your C and Java. When integer divide by integer, you get integer. Therefore, there will be truncation of your decimal places. So unit tests will help you to detect this kind of thing because sometimes we actually not sure, not aware. Because we thought it's like that, but sometimes it's not. The reality is not. And these kind of small things we actually just miss it and become a bug. Where sometimes it's difficult to trace back. So I want to show you another thing is another unit test where we want to actually test assertions. We want to test exceptions. Where we want to see whether when we run this thing, we provide a wrong value, whether this exception is being thrown or not. So sometimes when we run programs, when we try to do certain operations, we want to throw our own exceptions. But it will be quite difficult for us to do it live and make sure it fails. Then we get the exception and see, oh, okay, my code is working. So unit test is one of the ways for us to test whether in certain condition, it fits the condition and therefore it throws the error, the exception. So the way of writing the unit test will be something like this, where we say with self, assert, raises, rejects, where it checks in terms of the exception message. If it's missing, then okay, no problem. If it's not missing, then not okay. So let me show you the example. So let's say this unit test, we want to check whether when we run division by 0, whether we'll capture an exception where the message is called, haha, not funny at all. Alright? And if we run the unit test, we'll be able to see this message where we say that exception, assertion error, haha, not funny at all, does not match with the actual exception being thrown. In this case, the exception that's being thrown is actually haha, very funny. Okay? So this is a scenario where unit tests will be easier for us to test this on negative tests. Because usually when we run programs, we get positive replies, right? So that's very easy to test. Negative, you can use this way to do it. Okay, so let's look at another file. I'll go through with you the file that I've wrote, and perhaps when you go home, you have the right environment, you can actually test out the code yourself and write the unit test yourself. But at least I can explain you the code, and then you can understand what it tries to achieve, so that you can try again by yourself. Alright? So there's a second Python file that I wrote. It's called counting, where it does something minimally more complex than the first file, which is calculator, that does 4 operations. So what this file does is pretty simple. So it uses one Python library that is not in the standard library called YAML. It's called Python YAML, which you can download from. You can use there's 2 ways: either easy install or use the PIP way. If you look at the repo that I provided, inside has a file called init.sh, init.sh, and you can see how to install. So in the repo, there's a file called init.sh. You can open it up. So you can actually do this pip install PyYaml. Then you get this library in your computer. Right? Okay, so for this particular accounting class, what it does is that in the constructor, it does one thing. It loads a file called instructions.yaml.
Yeah.
And it saves into an instant variable called data. So we can have a look at that particular file. Where it's a very simple structured file that defines several human states. Earlier 1, 2, 4. And after that, on the second indentation, there's certain operations. It started with initial, then after that, it has mathematical operation of add, sub, multiplication, and division. Alright? So what it does is that perhaps we want to write a file where we want our program to auto compute the values. So we can write in this format and start with the initial value. So let's say for the early example, let's say the starting value is 1. When we do addition of 2 and 3, it means 1 plus 2 plus 3 lah. Okay, it becomes 6. Then after that, sub 1 means with minus 1, we get 5. Is it okay with this file? That's the operation. So for example, let's say we go for Mutu. Initial is 0, and we perform operation division and we divide by 3. What do we get? 0 divided by 3. 0, right?
Yeah.
Correct? 0, huh? Okay. Correct? 0, huh? And after that, this one 5 divided by 0, you get what? Error, correct? So, our first example is what? Initial is 5, multiplied by 10, so it becomes 50. And then 50, subtract 20, you get 30. And 30 you add 1, and you add 2, you get 33. Okay, that's the purpose of this file. So we need to write a program that actually get all this data into a data structure that Python can understand. And then after that, we can perform the operation in our code. So this particular file format we call YAML file, and there's a certain format you can get it from online. You can see how to write the YAML file in a list and dictionary format. And after that, you can play around with it, even using your Python terminal. So let me show you how to play around with Python terminal by loading this file. So let's say we are in the practice folder. We have this instruction.yaml. We start the Python terminal. After that, we import YAML. If your computer has YAML, if don't have, you need to install it. After that, what we can do is we open the file. And then we can try to load it. And you can see that Python will convert just now that file into this data structure. So you can see you have curly brackets and square brackets and stuff like that. These are in dictionary list format. So this is the purpose of this particular file, also the module. So as we come back here, so as we have the constructor that does load the instructions.yaml, you're going to get that particular data structure. Just now, you can see the dictionary of things. And then after that, we try to process the data. So let's say, given Ali, what result do we get? So we can run unit tests for it to validate whether it works or not. So I can show you an example. So what we do is that in the accounting class, we have a method called process. And process, we just give you the username or the person's name called Ahmad. And after that, we want to see whether after we do the calculation, we get 33 or not. And just now, if you look at the YAML file, you do the manual calculation, you will get 33 supposedly. Okay. So we can have a look at the code first before we come back to this file. All these codes are in the repository, so you can download later. So the method process, what it does is that accept the name, which just now we say the word Ahmad, right? Okay, then after that, it checks for the initial. Because we need a starting number to do calculation, right now. So if it's initial, then after that we do some magic here. So I'll keep it very simple because here it does quite a lot of things. You can try it out at home. To be simple, what it does is that it goes through every single operation. It tries to get all the numbers correctly, and then it computes the answer. Over here has, I think, some of the very important Python concepts in terms of how we write Python codes. That is slightly different from the conventional programming language like Java and also C++. So, for example, we have something like this in Python, where you can see is numbers equals to this particular thing. So what this particular thing does, there's an equivalent way of writing. If type
numbers.
So you can see here, in other languages, this thing is quite common, right? So we have a condition here. If the condition is true, then we do assignment, value assignment to numbers, or else we assign another thing to numbers. In Python, we can combine all of them into one line, and the way of writing is like this: numbers equals to, if the condition is true, then the value is here on the left side. Or else it is. Or else it will be this one. So that's how we write them in one line. One thing you also notice is that Python is a bit different from Java, a bit different from Java in terms of you don't really specify the variable has what data type, correct? You don't say whether is it a string, something like Ruby where you don't need to say string, you don't need to say is it integer or float or double or whatsoever, because Python will somehow derive it for you. Over here, let's say you are given a variable, you're not sure what type of variable is it. So in Python we have a very convenient way of checking where we can use this type and inside we put a variable. Then we'll be able to see what data type is that. So in this case, what we are trying to achieve is very simple. If the number variable is actually a list, then we just need to do this thing. Because in Python, when we want to combine two lists into one list, it will be list plus list. Something like when you try to merge your string, it's also string plus string. Okay? And if the numbers is not string, okay, if the number is not list, then it will be pretty simple where we just need to declare the list and we put the individual numbers inside and separated by a comma. So these are 101 typical things for how we formulate this data type or manipulate this data type. Over here, again, because we want to test against the accounting class, what we do, we want to make things simpler. We just put, we just declare or instantiate once inside the setup, so that we don't need to repeat the code in every single test case or test method. So over these 4 test cases, you can see that we have introduced a very convenient way of adding multiple values together, performing the operation involving more than two numbers. Because just now your calculator .py only accepts 2 numbers, right now, and perform the operation. So this one provides a feature where you can put multiple numbers. For example, let's say for x, we now put in 3 numbers, correct? Actually, you can do more than that. You want to put 4 also can. Okay, of course when you put 4 number, the test case will complain loud, right? No? Because we add another number 4, supposed to be 10, right? No? But at this moment, we put 6. Therefore, complaints, wrong additions. So what we need to do is just amend the numbers together. So we actually did something on the code side in accounting class where we access multiple arguments in a very flexible way. Python provides this feature since a long time back. Java only has this during Java 7. Okay, so that one, if you want to know more, you can check out the accounting class. There's some S3s there. Okay, that's the
Stack Overflow. The Stack Overflow link.
I think I provided a link.
Yeah.
Okay, the last thing that I want to show you is that just now we talked about process, we want to talk about Ali, Ahwan, Mutu, and we run test cases right now. Okay. This is actually example of wrong example. What is working? Correct? It's working because that's how all the test cases pass. But these four unit tests, these four tests is actually not really unit tests. Why I say so is because this particular method called process actually invokes another operation. Just now we talked about unit test is one single unit of work, correct? But this one does two. What are the two? First, before you can calculate, let's say Mutu's total value, the result, you must first load the value from the file, right now, from the YAML file. Then the next thing is what? You do the computation. Therefore, it's no longer single. You are doing two things at one time. Therefore, it's not really a very good unit test per se. Because sometimes the process is working, but maybe the file or something went wrong. But it's not your code's problem, right? So in unit test, we only want to test one thing. In this case, we want to test whether the processing, the computation of all the things, all the materials, is it working correctly as expected, and not whether the file is corrupted in this case. So the real answer, the real unit test is actually like this. Of course, you may need some time to try out at home. What we do is that we have a particular class in Python 3, a particular module that helps us to do something called mocking. Okay, mocking means we try to give a fake value or a fake actor to that particular things that we want to remove or to ignore. In this case, just now we say that in order to get a user's value, we need to do two things. One is load the file's value, second is do the computation. Since our unit test is supposed to focus on computation, right? We need to remove this factor of loading the value for file. So how do we do that? Is to fake that particular process, that particular thing where we want to fake YAML.load. That's the first thing. Second is we want to fake the file open. Because we need to open the file, then we let the module, the YAML module, to process the data, crunch the data into the Python data structure. So, over here, we fix YAML.load. That's the way of writing. We patch it, and after that, we set a fake value. Okay, we set a fake value. And I use the user callback because in the YAML file there's no such user callback. Okay, and after that, we have those steps or details of addition, subtraction, and whatsoever. And this thing will work because we already see, in a way, we simulated the first part of the process of loading, open the file, load the value. That part is being mocked, and therefore, this particular process only receives the value that's being mocked, which is this part, as defined in the return value. And because of that, you will be able to run this process, load the user box details, and then we can perform the calculation, and we get 5. In this case, initial is 1, and we perform addition operation 2 and 3, so 1 plus 2 plus 3, we get 6. And after that, we perform subtraction of 1, so 6 minus 1, we get 5. Right? So that's how we do it. So if you don't believe, you say, this further thing, okay, we change the value here and see whether is it really working or not. Let's say the subtraction, I change it to 3. Okay? Subtraction, I change to 3. So 1 plus 2 plus 3 minus 3, we get 3. Alright? Okay. Let me say now. So over here you see lots of things. It says that assert equals the process for 5 is actually not 3, and therefore wrong calculation. So in this case, you can see that based on the return value, if you amend the return value, then when you process it, you get a different value, correct? You get 3, and therefore it's different from 5. So this is a very important, this mock module is very important because it helps us to actually remove the noise. Okay, remove the noise because when we talk about unit tests, we only want to test one thing, not multiple things at one time. It's just like when you try to debug an error, you always try to nail down to one thing, correct? Do you try to debug things and you just go the entire code base and do everything you want? Not really, correct? You need to narrow it down to one thing to try to fix it. So unit tests have this type of concept where you need to drill down, focus on one thing and make sure it works. So that when you use it in other places, it will work as expected. And patch will help you. So what we import is actually the unit test module. There's a mock module, and we import the method called patch. Okay, the particular thing that we use for patch. So just to sum it up, I'm sorry that today we cannot go in detail, do a lot of coding because of the environment issue. But I hope to give you another 10 minutes later before the next session so that you can try to set up the environment so that it will be smoother later on for the next session. Just to sum up this thing, this slide I will also include in the repo so that you can download the slide, you can refer yourself and try to do things. So supposedly what we go through is we try to write a simple calculator program. After that, we try to work on assertion, which is validation. We try to see whether we get the right value or not. Then after that, we also learn how to set up. Supposedly we can learn that out. And then after that, last thing, we have mock and patch, where we try to make sure that we only test one thing, not multiple things at one time. And this one you can explore further. Thankfully, Python's documentation is really not bad, and you can actually read it. It's quite readable as compared to some other languages. Okay, so all these things is covered in the code in the repository, so you can check it out later in the source folder. The last thing is I will try to sell to you this idea of unit testing and how to integrate as part of your workflow. Usually, there are two common ways of doing it. The first part is that as you write your code, you write the unit test, and after that, during integration, means during when you build your application, before you push to certain environment or push to production, you run the test one round and make sure that there's no error, make sure everything is okay. Then you can push to production. So that's the first thing. Validate your work and integrate into your environment. But there's also another way of doing things. Some people say that we call TDD, which is test-driven development. So it's something like just now, where when I first started the calculator, I create a method. Before I write everything done, I actually start writing the test. And I write what I expect it to be before I fill in the code itself in terms of return number 1 plus number 2. I write the test, so the test will fail because I haven't write the start of the real calculator.py and so forth. So that is what we call test-driven development, where we try to write the test as long as we write the code. This could be useful at times because sometimes I'm not sure about your working environment. Sometimes when you work, you talk to people, right? Sometimes when you develop codes, you chat with people. I mean, text chat. sometimes when you develop code, don't know why you go to Facebook. Correct? So you're not really fully focused, and sometimes it may slip through your eyes in terms of what you do. Sometimes you may just do a certain wrong operation. And it is quite troublesome when you are being given a task to write, let's say, 100 lines, and you only test the code after you finish writing 100 lines. And when you have an error, you have no idea where to check because somewhere it's 100 lines of code. So maybe when you write your code and you write tests at the same time, it may help you to counter check or counter validate real time, so that it's easier. So it's back to your own preference, whether you want to finish writing the code, then you write your tests and validate later, or you can write your tests as you write your code, so that you can validate roughly real time in a sense. Of course, in practice, sometimes I do that, sometimes most of the time I do that. I write my code first, then I test. So it depends on the use case, and it depends on how flexible it is to test your code. If it's flexible, then try to do it more frequent rather than just finish all the code like 1,000 lines and then do the testing. That will be very good. Alright. So what I do in my workplace and what the company does, we use unit tests as our development process. So every single line of code that we have to write unit tests, or we should write unit tests. And we have something called continuous integration. So what we do is that we use Git. So after we write our code, we will push to our repository, and then we have a server that actually automatically pull the code and then run the test to make sure all the tests pass. If the test fail, you get a red color, which is something went wrong. Then we can go in and check the error message, see what's wrong with it, and maybe we can curse the person because the person didn't check his code before we push into the repository. We also use behavioral tests. So behavioral test is something a bit different, where we actually check the behavior. So there are some famous tools for it. One of it is called Cucumber, where we actually can write human-readable scenarios of things that we want to check. Then after that, at background, we have certain codes to run that particular test validating. So we also do that. And lastly, we also do performance tests. It's a very nasty thing to do. It takes a lot of time. But sometimes when we do performance testing, we actually realize whether the code that we have introduced makes the system slow or makes the system faster. So these are the common tests that we can do on top of unit testing that actually help your development. And if you want to know more details, perhaps you can talk to me or you can even talk to Sweeting personally. I don't know who's that guy, but he used to be with on that, so he also knows the details. So if I'm lazy, you can talk to him. So last thing, I was told that I need to do this marketing. So we are hiring, and we are looking for system admins, and we are looking for software developers. Generally, we do a lot of wonderful things. We do a lot of very, very different things. You can see the list of things that we use. We use Python, we use Java. Python and Java is our two main languages in the company. And we do use some miscellaneous languages for certain scenarios because we believe in the best. We don't believe in one language, we believe in what suits the task. So if this language or this particular tool actually can make things better or faster, we use it. So in this case, we have miscellaneous languages like Ruby, Lua, even these other things. And we also use some tools that is quite famous, Nginx for HTTP, Wildar for streaming. We use Puppet for provisioning, which is to set up servers and stuff, or set up environment. Vagrant, the one that I asked you to set up, is to spin up virtual machines. We also started using Docker about 3 months back. Very useful, to say. And our main environment is Debian. We use Debian to do everything, including our servers. Cucumber is a behavioral testing that we use. We use RabbitMQ for messaging. We use MariaDB, which is an open source so-called truly open source version of the bicycle after it's being bought over by Oracle. We somehow use MongoDB, but we stopped expanding the MongoDB. It's very nasty. And we also started using something called ELK, which is Elasticsearch, Logstash, for visualization of logs, for visibility of our performance and stuff. So if you're interested, if you wish to know more about openings, you can talk to me. And for the next 2 days, there will be people somehow, the HR people will be around for the next 2 days. If you're not mistaken, you can talk to them also. There should be a counter lab. I'll be around next day if you're interested to know more about what I do and stuff. So, thank you. Any questions? No question. I strongly encourage you to set up the Vagrant so that you can have a working environment for the next session. So thank you. And sorry we didn't have much internet time because I think it's been quite unorganized. I think next time we should make sure the PCs have suitable environment.
Yeah.
Okay, so I hand over the time to
That was a piece of the Salasin.10 podcasterium. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels. That was a piece of the Salasin.10 podcasterium. It is hoped that you have enjoyed it. If you have any issues, please feel free to leave a comment through any of the channels.